Hello dear students, welcome back to my channel. Today we will discuss about the similarity criteria. Before going to the criteria, so we will come to know or we will know about the similarity of triangles. So consider any two triangles. Let triangle ABC and another one triangle we call it as DEF. Let this be ABC and this triangle as DEF. Now, so if these two triangles are said to be similar, so you studied about congruency in the 9th standard, and we will discuss about similarity in this class. That is, if these two triangles are said to be similar, these two triangles should satisfy two conditions. Those are, the first one is the corresponding angles must be equal. That is, angle A and angle D are corresponding angles. Angle B and angle E are corresponding angles. Angle C and angle F are corresponding angles. That is, angle A is equals to angle D, corresponding angles. Angle B is equals to angle E, and angle C is equals to angle F. The corresponding angles are equal. And the second condition is corresponding sides must be in the same ratio, or this can also be stated as the ratio of corresponding sides are equal, or they are in the same proportion. That is, for AB, DE is the corresponding side. That is, ratio means we have to write AB divided by DE. And for side BC, EF is the corresponding side. And for AC, DF is the corresponding side. That is, AC divided by DF. So, as I said already, the ratio of corresponding sides must be equal. That is, AB by DE is equals to BC by EF, which is again equals to AC by EF. If these two triangles satisfies these two conditions, that is, condition 1 is the corresponding angles must be equal, and the condition 2 is the ratio of corresponding sides must be equal. So if these two conditions are satisfied by those two triangles, then we can say triangle ABC is similar to, this is the symbol of similarity, similar to triangle DEF. This is the condition of similarity. Okay, and now we will know about the criteria of similarity. Criteria of similarity. So in the 9th standard, you have already learnt about criteria of congruency. In the same way, here also we have to study about criteria of similarity. Which means, so those are three criteria here. First one is A similarity criteria. A similarity criteria. So A means here angle similarity criteria. And second one is SSS similarity criteria. Here SSS means side similarity criteria. And the third one is SAS similarity criteria. Side similarity criteria. And now we will discuss about this first criteria, that is angle similarity criteria in this session. Now we will discuss about the theorem 3, AAA similarity theorem, as I said earlier. So we will discuss angle, that is angle similarity theorem, that is first criteria. So the statement we will see now. Statement: if in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio, and hence the two triangles are similar. We have to prove this theorem now. So for that we have to write the data here. Data are given, whatever you can take. So here there are two triangles we have taken, that is triangle ABC and triangle DEF. In these triangles, that is triangle ABC and triangle DEF, as I said in the earlier theorems, previous theorems, so the first part of statement will give you the data, and the next part of the statement will give you the what we have to prove. So first part, if in two triangles, that is in these two triangles, the corresponding angles are equal. So this is the data, that's it. That is, the corresponding angles are angle A and angle D. Angle A is equals to angle D, and angle B is equals to angle E, and again angle C is equals to angle F. This is the data which is obtained from the statement, that is corresponding angles are equal. We have written in these two triangles the corresponding angles, that is A is equals to D, angle B is equals to angle E, angle C is equals to angle F. You have to observe this very clearly. Now the next step is what we have to prove, that is to prove. So I said already, the second part of the statement will give you the prove, what we have to prove, that is then their corresponding sides are in the same ratio. This is what we need to prove now. The corresponding sides are in the same ratio, that is AB divided by DE is equals to BC divided by EF, which is again equals to AC divided by DF. I will show here. AB divided by DE is equals to BC divided by EF, and again AC divided by DF. All these corresponding sides are in the same ratio. This is what we need to prove, and again we need to prove, here it is continued, hence the two triangles are similar. Again we have to prove, we can take this as first one, and the second again we have to prove that triangle ABC is similar to triangle DEF. This is what we need to prove in this theorem. So the followed by the next step is construction. What we have to construct here now is, you have to measure the length of AB, means just you have to analyze this. AB as same as the length of AB, you have to mark a point. Let we can take this as point P, which should be same as that of AB, which means the length of AB and the length of DB are same. In the same way, you have to measure the length of AC. For a same distance, you need to mark a point Q, which is on DF. P on DE and Q on DF. You need to measure the AB and AC and mark point P and Q. And next we have to join those two points. That is you will get another one. You will get another one triangle DPQ. So just write here what we constructed in the figure. You have to write that thing here. That is, draw. You have to draw DP, which is equals to AB, which means the length of DP is same as that of AB, and DQ, which is same as that of the length of DP is same as that of AC. And again we have joined, that is join P and Q. You joined here na, P to Q. You have to write that P and Q we have joined here. So this is the construction. Now the next step is proof. Yes, now consider, we can take that I have drawn the figure here. Just observe the figure. So that is, we have to consider triangle ABC and a newly formed triangle DPQ. We will consider these two triangles, that is in triangle ABC and triangle DPQ, in these two triangles. So just observe here. So in the construction we have drawn like this, that is DP is equals to AB, DQ is equals to AC, which means the length of AB and length of DP are equal. That is, AB is equals to DP. In the same way, AC is equals to DQ. AC is equals to DQ. So these are two from the construction. You have to write here. That is from construction. From construction we have written like this. So and now, so the data is there. That is, the corresponding angles are equal. Angle A is equals to D. So I will use that thing here. Angle A is equals to angle D. This is from data. So you just remember the SAS congruency rule from the 9th standard. That is, yes, these two corresponding sides are equal and these two corresponding sides are equal, and this is an inclined angle of those two sides. That is, from SAS criteria I can tell that triangle ABC is congruent to triangle DEF. You have to write the reason. That is SAS congruency. SAS congruency. This is you studied in the 9th standard. The congruency rules are studied in the 9th standard. So if these two triangles are said to be congruent, the corresponding angles are equal. That is, by CPCT I can write angle B is equals to angle P. This angle B is equals to angle P. So because these two are the corresponding angles for the congruent triangles, because ABC and DPQ are congruent triangles, we just proved here. So angle B and angle P are congruent and corresponding angles. Angle C and angle Q are also corresponding angles. Again I can write angle C is equals to angle Q. So this is by CPCT. CPCT means corresponding parts of congruent triangle. So these two are the corresponding parts of these two congruent triangle. You can take this as equation number 1. Now compare this equation 1 and the data. I will show here now the data. Here is the data. That is, angle A is equals to angle D, angle B is equals to angle E, angle C is equals to angle F. So now, and equation 1 is angle B is equals to P. So I will write the given here just for the reference, that is angle A is equals to angle D, angle B is equals to angle E, and angle C is equals to angle F. This is the given. You need not to write in your notes. So just for the reference or to show the given to you, I have written here. So observe here, angle B is equals to P. Here angle B is equals to angle E, which means the things which are equal to the same thing are equal to one another. You have learned this axiom in the 9th standard axioms and postulates chapter. That is, we will compare. We have to compare equation 1 with data, or equation 1 and data. We can write, so here B is equals to P and B is equals to E, which means I can write angle P is equals to angle E. Angle P is equals to angle E. So this is by axiom. So which is that axiom, sir? Means the things which are equal to the same thing. Here B is equals to P, B is equals to E. The things which are means P is equals to B, E is equals to B. So the things which are equal to the same thing are equal to one another. That is angle P is equals to angle E. So I will show why I have proved that thing. He observed the figure here. Just I proved that angle B is equals to P from the CPCT. And now I have proved angle P is equals to angle E. Observe here, these two are corresponding angles. If their corresponding angles are equal, so we can tell that PQ is parallel to EF. You have to go for the previous knowledge, that is, if the corresponding angles are equal, those two lines are said to be parallel. So we will use that concept here, that is PQ parallel to EF. So if P is equals to E means PQ is parallel to EF. This is from the corresponding angle theorem. Corresponding angle theorem, or you can just write corresponding angles. P and E are corresponding angles. So we have written PQ parallel to EF. Now we will take the next step, that is, just observe the second triangle, that is triangle DEF. In this triangle DEF, PQ is parallel to EF. We just proved it now. So in triangle DEF, this triangle, in triangle DEF, PQ is parallel to EF. PQ is parallel to EF. So why I have written like this? I can apply BPT for this second triangle. So in the BPT we know that if a line is parallel to any one side of a triangle which divides the other two sides in the same ratio. So I can take DP divided by PE and DQ divided by QF. But I will not take DP by PE. I will take DP by DE. Just in the previous video I have explained the example 1. So in that video you can go through that. I can write DP by DE, that is same as that of BPT. DP divided by DE, which is equals to DQ divided by DF. This is we have written from BPT. So we have proved the example 1 by using the BPT. So I can written DP by DE is equals to DQ by DF. So we have written here. So now I will just replace some values here, that is, so observe here, DP is same as that of AB and DQ is same as that of AC. So I will replace DP by AB, which will not make any change, because from the construction we know that DP is same as that of AB, DQ is same as that of AC. I will just replace in the next step. By D, in place of DP I can write AB. You can observe the figure here, AB divided by DE, which is equals to, in place of DQ I can write AC by DF. You need to take the reference of the figure continuously and very carefully here. So we get AB by DE is equals to AC by DF. You can take this as equation number 2. Now just imagine if we draw this line PQ which is parallel to EF. By drawing like this, if we draw this to DE and EF, that is like this, if we draw like this, so what we have got, the equation 2 is changed as, that is, we can write similarly here. Similarly we may get this as AB by DE. AB by DE is equals to BC by EF, which is equals to BC by EF. There is no need to prove again by using this, so we can just write similarly. You can just write similarly and write AB divided by DE is equals to BC divided by EF. So you can name this as equation number 3. Now combine equation 2 and equation 3. Combining equation 1, 2 and equation 3. So by combining means here AB by DE and AB by DE is common in both the equation. So we can combine these 3, that is AB by DE is equals to BC by EF is equals to AC by DF. This is what we need. So in the to prove we have written this thing. I will show that here. So to prove is here, AB by DE is equals to BC by EF is equals to AC by DF. So the same thing we proved here, AB by DE is equals to BC by EF is equals to AC by DF. So the first thing or first one is proved, and we need to prove this one, triangle ABC similar to triangle DEF. That's very simple. So for that you need to name this as equation number 4. So observe equation 4. So the corresponding sides of those two triangles, that is, see here, AB divided by DE, BC divided by EF and AC divided by DF are in the same ratio. In the data we know already the corresponding angles are equal, and in equation 4 the corresponding sides are in the same ratio. Just remember the definition what I have said in the first or starting of this video, that is, if any two triangles are said to be similar, they have to satisfy two conditions. The first condition is the corresponding angles must be equal. That's already given in the statement, that is in the data we have already written. And correspond in the second criteria is the corresponding sides must be in the same ratio. That is we proved in the equation 4. So by data and equation 4 we can write triangle ABC is similar to triangle DEF. Triangle DEF. So by definition we can take this by definition, or there is no need to write here, we have written here already. By data, in the data corresponding angles are equal. This is first one. Equation 4 tells that the corresponding sides are in the same ratio. These two triangles, that is triangle ABC, and triangle DEF are satisfying both the conditions. We can tell that triangle ABC is similar to triangle DEF. So this is what we required, hence proved. We proved both the things here. The AB by DE is equals to BC by EF is equals to AC by DF. This is the first point in what we need to prove, and this is the second point. Triangle ABC and triangle DEF are similar, hence proved. Okay, dear students, you need to write all these theorems daily at least once, then you will get perfect all those. So thank you. Please subscribe my channel and like the video. Thank you once again.